Before I discovered what makes SAT questions truly challenging, I was just like many of you, spending hours tackling practice exams only to find out that some questions just don't make sense. So today, I'm going to walk you through 6 of the hardest SAT questions from this year. I've also prepared a PDF document where you can have access to these questions in the description below. Make sure that before I solve each question, you try it yourself and at the end comment down below how many of these you got correct. Let's get started with the first one. This one stumped a lot of students, and it's all about functions and constants. Now, it's given that the function passes through 2 specific points, -7, 24, and 899. And here's where it gets really interesting. We need to figure out the values of p of -12 and p -5. Remember that this is a real SAT question that students encountered. But how do we even start? Let's take it step by step and reveal what we find. First, let's substitute the point -724 into the function. What does that give us? Well, we have p of -7 equals to 24. So if we plug -7 into our function, we get a multiplied by -7 plus 6 squared minus b multiplied by -7 plus 6 squared minus c equals 24. Do you see where this is going? By simplifying, we have a multiplied by 1 minus b multiplied by 1 minus c, which equals to 24. So now we have equation 1. But what happens when we substitute the other points? 899. Let's see. P of 0 equals 899. If we plug in 0, we get a multiplied by 36 minus b multiplied by 36 minus c, which equals 899. Now we're starting to see a pattern. We got 2 equations, but no values for p of -12 and p of -5 yet. So how can we solve this puzzle? Here's the trick. Let's investigate what happens at other points. Now we can investigate the equations at other points, like p of -12 and p of -5. These might just reveal the final piece of the puzzle. Let's start with p of -12. We know from our original function that p of -12 equals a multiplied by -12 plus 6 squared minus b multiplied by -12 plus 6 squared minus c. And what do you know? This is the same calculation as p of 0, meaning that p of 12 equals 899. That's one piece. Now what about p of -5? P of -5 equals a multiplied by -5 plus 6 squared minus b multiplied by -5 plus 6 squared minus c. So p of -5 equals a multiplied by 1 minus b multiplied 1 minus c. This is the same calculation as pi, so it's equal to 24. But here is where it all comes together. What if we add p of -12 and p of -5? What will we get? That sum leads to our final answer. 899 plus 24 equals 923. So there it is. Our answer is 923. Question number 2. Imagine you're walking through a mysterious library filled with all sorts of puzzles and secrets. You come across an expression. Fifth root of 119n multiplied by fourth root of 119n squared. And there is a note attached to it saying, find the value of x so that this expression is equivalent to 119n in the power of 30x. At first, it seems straightforward, but as you start exploring, you realize there is more than meets the eye. You think, let's start by breaking it down. So you rewrite each part of the expression in terms of the exponents. First step is fifth root of 119n. You know that roots can be converted into exponents, so fifth root of 119n equals 119n in the power of 1 over 5. Alright, that seems simple enough. But what about the next part? Fourth root of 119n squared. You're about to find out. What you do is rewrite fourth root of 119n as an exponent. Fourth root of 119n equals 119n in the power of 1 over 4. So far so good, but then there is that square hanging outside, which makes you wonder, how does this even change things? And then you decide to tackle it. Fourth root of 119n squared equals to 119n in the power of 1 over 4 in the power of 2. So you get 119n in the power of 1 over 2. Now you're getting somewhere. You've successfully transformed both parts of the expression. But what's next? And then you realize it's time to combine them. So you rewrite 119n in the power of 1 over 5 multiplied by 119n in the power of 1 over 2. You remember that when multiplying terms with the same base, you can just add the exponents. But what does that give you here? 119n in the 119n in the power of 1 over 5 plus 1 over 2. But now you're left with the challenge of adding these two fractions. And then you pause and think, what's the common denominator? Then it clicks. The common denominator is 10. So you proceed to find 1 over 5 plus 1 over 2, and that equals to 2 over 10 plus 5 over 10, and that equals to 7 over 10. Now your expression is simplified to 119n in the power of 7 over 10. But there is still one more mystery. You need this to match the fourth 119n in the power of 30x. What should x be to make this work? You set the exponents equal to each other. 7 over 10 equals 30x. A tricky equation to solve, but not impossible. Dividing both sides by 30, and you find x equals 7 over 300. Finally, the pieces fall into place. You've solved the puzzle, revealing that the value of x equals 7 over 300. Another secret unearthed in the library of mathematical mysteries. Question number 3. Picture yourself in a world where numbers hold secrets. You stumble upon two intriguing equations. A equals 7,900% of C. C equals 0.08% of B. The challenge? To unravel these mysteries and find the value of A plus B in terms of C. At first glance, it seems like a small percentage puzzle. But you realize there is more than meets the eye. You begin with the first equation. A equals 7,900% of C. Now, 7,900% sounds huge, right? So you quickly decide to convert it into a more manageable decimal. 7,900% equals 79. This gives you A equals 79 multiplied by C. But that's only half the story. You still have the second equation waiting for you. So you turn it into where C equals 0.008% of B. Another percentage, an incredible tiny one. What could it mean? Now let's convert it. C equals 0.408 multiplied by B. Now you're curious, how do C and B relate? You isolate B by rearranging the equation. And then you pause, realizing that you're into something. After simplifying further, you get b equals 12,500 multiplied by c. But there is more. Now that you know both a and b in terms of c, what's next? It's time to uncover the combined value of a and b. And then you write a plus b equals 79c plus 12,500c. So then you add them together. A plus b equals 79 plus 12,500c, which simplifies to a plus b equals 12,579c. Finally, the answer is revealed, 12,579c. But as you step back, you realize it wasn't just about the numbers. It was about finding connections and hidden values where they seemed least likely to exist. In this world of percentages, you're just cracked the code. Question number 4. Imagine this, you're staring at two equations. They look different at first glance, but then you realize something odd. You simplify one and suddenly it becomes identical to the other. You're thinking, wait, what does that mean? But here's where things get really interesting. Let's break it down. You're given this system of equations. 2x plus 5y equals 3. 8x plus 20y equals 12. This second equation seems a bit daunting, so let's simplify it by dividing by 4. 8x divided by 4 plus 20y divided by 4 equals 12 divided by 4. And just like that, it simplifies to 2x plus 5y equals 3. Hold on, these two equations are actually the same. You're not dealing with two different lines. You're dealing with one line, expressed in two ways. So what now? Now we need to find which of our options actually lies on this line. There are 4 options, but only one of them will satisfy this line's equation. Let's test them out. Option A. So let's plug it in. 2r plus 5 multiplied by minus 5r divided by 2 plus 3 over 2, and that equals to 3. It starts to get messy. Simplifying this expression, we find that we end up with minus 21r plus 15 equals 6. So r is 3 over 7. But you're not done. We still have 3 options left. Let's see if any of these choices can prove themselves better. Option B. This one looks a little friendlier to work with. 2r plus 5 multiplied by 2r over 5 plus 3 over 5 equals 3. When we expand and simplify, we find that 4r plus 3 equals 3, which means that r equals 0. For option C, 2 multiplied by r over 4 plus 3 plus 5 multiplied by minus r over 4 plus 12 equals 13. After a lot of algebra, we end up with minus 3r over 4 equals minus 63. And that gives us a very huge number for r. A bit unwieldy, don't you think? And now for option D. Once we substitute this into the equation, something very remarkable happens. Minus 5r plus 3 plus 5r equals 3. Everything cancels out perfectly, leaving a true statement. So option D satisfies the equation perfectly without any complicated leftover terms or constants to worry about. And there you have it. When both equations in a system are actually the same, you're only dealing with one line. To find a point on that line, we needed a value that made everything cancel out smoothly. So option D was the one we were looking for. Question number 5. Let's unravel the mystery of finding P for a polygon with 73 sides, where each interior angle is represented by 180p. This task calls for a mathematical journey through geometry. So let's dive in. The first steps to solving this question correct is recalling the interior angle formula for polygons. So the formula for the interior angle of a regular polygon with n sides is given by interior angle equals n minus 2 multiplied by 180 divided by n. So our second step is plugging in the number of sides. Since we know our polygon has 73 sides, substitute n equals 73. So interior angle equals 73 minus 2 multiplied by 180 divided by 73. So that equals to 71 multiplied by 180 divided by 73. And our third step is by far one of the most crucial ones, which is simplifying the expression. Now let's simplify it. Interior angle equals 71 multiplied by 180 divided by 73. This gives us the exact formula for each interior angle based on the sides of the polygon. But we are given that each angle measures 180p degrees. And our fourth step is setting up the equation. Since each angle measures 180p degrees, we set the two expressions equal to each other. 71 multiplied by 180 degrees divided by 73 equals 180p. And our fifth step is solving for p. To isolate p, let's divide both sides by 180. P equals 71 multiplied by 180 divided by 73 multiplied by 180. And that gives us 71 over 73. And our final, but one of the most important steps is confirming the approximation. By going through all these 6 steps, we found that p equals 71 divided by 73. Question number 6. As exemplified by songs about the natural environment and autumn songs about deserts, plains, ecological information can be transmitted in indigenous songs and in some instances is maintained only in this way. A songkeeper for those people in Canada collaborated with ethnobiologist Dana, sharing songs referencing those gardens the people implemented in the past to foster healthy development of dietary staple. Drawing on archaeological evidence as well, he determines that the prevalence of the practice described in the songs corresponded with growth in clam size and evidence despite increases harvesting pressure, a finding that demonstrates that. Now let's dive into the narrative of this passage. We're discussing how indigenous songs, particularly from those people, serve as vessels for ecological knowledge. The example given is the songs that mention clam gardens, terrace created to cultivate clams. And then the passage explains that these gardens weren't only effective but led to larger clams and greater abundance, despite ongoing harvesting. But given this rich detail, we need to choose the most logical completion to convey this main idea. Now, the best strategy is to analyze the options based on this context. Option A. Effective methods for the cultivation of sources of sustenance are among the ecological knowledge preserved in indigenous songs. This directly reflects the passage's message. It underscores that the songs preserved knowledge about effective sustenance cultivation methods, which ties perfectly with the column garden example provided. This option is a strong contender. Choice B. Those people likely would not have detailed their creation of clam gardens in songs if their efforts had not produced significantly larger clams. This option introduces speculation which likely would not have, which detracts from the passage's definitive tone, and it also speculates on what the people might have done rather than focusing on what the songs indeed contain. So then this doesn't align as directly with the passage. Choice C. The clams harvested from terraces by those people in the past likely were a different species than the clams found in those areas today. While this choice is interesting, this option veers off topic. The passage is about effective methods preserved in songs. not about species variation over time. But the mention of species is a distraction from the main point. Option Z, representation of practical applications of ecological knowledge is the defining characteristic of the music of certain indigenous people. While this choice is insightful, this is a very broad generalization that doesn't specifically align with the passage's narrow focus on clam cultivation practices. But after weighing these options, option A is clearly the most logical and direct match, as it emphasizes that indigenous science preserve effective ecological practices. Therefore, the best answer is A. Now, if you're serious about taking your prep to the next level, click on this video where we break down the most effective strategies that will save your time on test day. It's packed with techniques that will make even the hardest questions seem easy. And remember, I'm dropping some more SAT tips almost every week, so hit that subscribe button and stay tuned.